Hello children, in this video we are going to learn a little about sequences. For this purpose I have my son here. He is in fact a mathematics graduate and he feels that some easy and basic concepts which he would have liked to learn when he was in his school days, like which could have been introduced in his school days, were missing then. So he would like to speak a little about sequences. It's like a discussion, but you will learn a lot. So let's take it as an introduction to our chapter, the arithmetic progression. Yes, Ishwar?
Yeah, thank you. So, what I feel is in our school we learn about arithmetic sequences. Some of you might have learned already,
Okay.
but we first of all have to answer the question: what are sequences?
Okay.
And maybe kind of develop it into a proper definition of some sort.
Okay.
So, can you maybe consider calendar daily weather reports, for example,
Okay.
and you start from today and you make a list of weather reports daily. So today may be day one, and you take the average temperature and you write it down. Maybe it's 31 degrees here maybe.
Okay.
So I'll just write 31 for it, and you go about the same process the day tomorrow and the day after. So
Okay.
maybe it's 30 and you get a 28 degree, and maybe you get
Till some date, is it? Till a particular day?
and you do this ideally for always,
Oh,
for eternity.
okay.
This is a very natural thing to do because weather reports work this way. So maybe they work up to some days, and you can actually predict what the next day's weather will be with this data,
Yeah, yeah.
with the data we already have. So this might be a very good application of sequences also further, but we're not interested in that. We are now interested in making observations about our kind of list we had created. So I am calling this a list loosely without
In English, we call it a list.
yeah. So without getting into much details, I'm calling it a list because we are used to the term. First of all, we see that no matter what number I give you, say that you are a computer of some sort, and no matter what integer, a positive integer I give you, say 85, you should have a corresponding weather entry for that 85.
You mean day 85?
So that will be the weather corresponding to the 85th day in your list.
Okay.
So does this make sense that for every number you are able to find one temperature?
Yes. Every day we'll have some reading, some temperature reading.
Okay, so this is one observation. So there exists a reading, right? I'll call it maybe some R. R is my number, and R should belong to, in this case, a temperature. So it can be any real number.
Oh, yes.
Okay. So we can call this a list of real numbers if you want.
Okay, but I don't think temperatures would be irrational.
Yeah, but yeah, it's fine. Okay, you won't measure up to that accuracy, of course.
Yeah, okay.
So it can be rational numbers if you want. One other observation is uh, so another observation can be there is no set pattern in the weather reports of.
Oh, you mean that there is no common difference, a constant difference?
They can. So, for example, we can have something like this: 1, 1, 2. Okay, I'll write it this way. We can have 1, 0, 1, 0, 1, 0. This forms a list, right? I'm just writing it in a different way, but this forms a list.
Oh,
But you'll still be able to predict what the next term in the list is without me explicitly telling you what it does.
oh.
I think you should have some logical understanding of what is happening.
Yeah, 1 0 1 0.
They are alternating, right? But this list won't have any pattern, any such pattern. Even it does not have a common difference, of course, and it does not have any other pattern whatsoever. You just go out, you measure the weather, and you write it.
Yeah. Yes.
So the predictability is not there. You don't predict the next entry
Okay.
using any set formula or any set idea.
This is very much different from what we are learning, arithmetic
Exactly.
sequence.
So this is some sort of a general definition of a sequence.
Okay.
So for a sequence, it should be some set of numbers that form a list. And by a list, I mean you can write it down as one, in point wise. You can give numbers to it, and for each number, there exists an associated output for it.
Okay, there is some reading for every number.
Exactly. So, can I give you some more examples of if you are convinced with the kind of general idea of sequences?
Okay. Yes. Yes.
So, can I give you some examples too? Maybe you can tell me if it's a sequence or not.
Sure.
Maybe that will work. So, I give you one sequence. I am writing it in now a comma fashion.
Okay.
I won't make.
No, you won't number them.
Yeah, I'm not going to number them, but it's understood that this is the first entry and this is the nth entry.
Okay.
So this is my set of numbers: 3.1, 3.14, 3.141, 3.1415, and so on. So does this constitute a sequence? Maybe. What do you think?
It may, because of course you said that a sequence need not have any constant difference. So and it has a reading for every number. I mean every term. If I can call it term, just like I call it in arithmetic series.
Yes, you can. So there are terms of a sequence, and so for every term,
it is a sequence. But can I predict the next number? I am not sure.
You don't need to. That's the whole point.
Okay.
So what we discussed here is you actually don't need to predict the next number.
Okay.
There is no set idea behind it. It might be random, but it's still a sequence.
Okay.
And a very small subset of maybe subclass of sequences, you can predict the next thing, and that's what we are interested about in mathematics, in discussing.
Okay, but may I ask you this? Now this looks like it is.
It is random, but I'll tell you what it is. It's actually it's nothing fancy. It's just a decimal expansion of pi.
Oh, I thought
so. So pi is 3.14159, and it goes on.
Oh, okay.
Right, it's irrational, so it never repeats. It never. So there's no set pattern, of course.
Okay, right. Irrational numbers themselves are random. So.
Yeah, irrational. Yeah, exactly. So I'm just putting it down in a.
Okay.
So this is one sequence. So now what I gave you here 1010, this was a sequence.
Okay.
Right? And maybe a sequence that we are used to is 1, 3, 5, 7, 9, 11, 13. Can you guess?
Yeah, these are prime numbers in our natural numbers.
Okay, but are they prime? What about 9?
Oh, 9 is not prime. 9 is not prime.
So I've done nothing actually. There's just I'm adding 2 to 1 each time.
Oh.
Like I'm adding 2 to the sequence.
Okay, this is what we are learning.
Yeah, we are going to observe further, and I think your further videos will cover this. But this is also a sequence, right? And yes, you gave a very good example there. The sequence of primes. So 1 is not a prime. So I'll start from 2, 3, 5, 7, 11. I only got 9, 13,
17.
17. Yeah, you'll have to help me here. I'm bad 19. At this. Yeah. Okay, so this will form a sequence. Again, the sequence, you know what the next term is, but you cannot predict it. There's an idea underlying.
Okay.
And for any nth given
actually we can predict it, but there is no difference. There is no constant difference between the two numbers, two terms.
Right. You're right. So that's what I mean. If I give you the nth term, I ask you the nth prime number. Oh. Of course, there are ways to go about it, but Without
Okay.
those algorithms, you cannot.
Yeah. Now I can only predict the next term.
Exactly.
Yeah.
So this is a sequence. Maybe I'll end with a few more examples and then we'll be done. Right? So maybe this is a sequence. 7, 7, 7, 7. So of course, can you predict the next term?
Of course, it is 7, 7, 7. Actually, we can call this as 7 plus 0 plus 0 plus 0 also.
Yeah, if you want to write it in that form.
Yeah, or 7 multiplied by 1. Every term is multiplied by 1.
Yeah.
Okay.
Or every term you add 2 and subtract 2. You can do any, but it's just a constant.
But even without doing anything, I can say all the other terms
it's a
are
constant
7.
sequence.
It's a okay, constant sequence.
So talking about multiplication, which you don't need to actually bother much, but you'll learn it later, much later in school, I think.
Okay, not now.
Not now. So 1, 2, 4, 8, 16. So intuitively, I think you might have some idea about the next term. You don't know.
Squaring every term.
Yeah, kind of. I'm not. I'm actually multiplying every term by.
You're
2.
squaring. You're multiplying by 2. Okay, 2 into 2, 4, 4 into 2, 8, 8 into 2. Yeah, you're multiplying by 2.
Or I'm taking the powers of 2. So 2 to the power n would give me the nth term. 2 to the power. This is my.
Okay.
Okay, so
So first is 2 to the power 0, then 2 to the power
so
1, 2
I'll
to the power 2. Okay.
Yeah, so I'll just 2 to the power 1 is 2, to the power 2 is 4. Yeah.
Okay.
First is 2 to the power 0.
Okay.
So n minus 1 if you start n from 1 or. Okay, all that we don't need to bother about. See, I might. Sometimes my arguments might get a little too mathy for.
Okay. No, we'll ignore that.
Yeah. So, but we do have a sequence. We got it by multiplying the previous term by 2.
As I said, maybe even squares are sequences, right? 1 into 1, 2 into
1. And 2 square is 4. 3 square
4
is
square.
9.
Acha, 3 square. Okay.
4 square is 6. So each the place it occupies in the list, I am squaring that corresponding list number.
Okay. So I got it.
Right. So if this is my list, so I am corresponding. I'm squaring 1. I'm squaring 4.
3
I'm
square.
squaring 9.
4 square. Yeah.
Right.
So this is also a sequence. Okay.
So unless and until you can give me an output for every term in the sequence, it is a sequence.
Okay.
So think of this computer when you are lost. So you will have to judge whether for any whole number or natural number inputted, you need to find a output. So these are sequences. Arithmetic sequences, of course, are a small class where the difference
is constant.
I think we had this one here. Right?
The first one, 1, 3, 5, 7.
Yeah. So the difference is constant. Each time the difference is 2. So this is an arithmetic.
It's an arithmetic sequence.
I think this is enough, right?
Yeah, this is a good introduction to arithmetic sequences also. So we have introduced 1, 3, 5, 7, 9. A constant difference.
Yeah.
Yeah.
Okay.
Thank you.